Hey guys, my name is Nurbek. Today we're gonna talk about what is discrete mathematics. Discrete mathematics is a part of mathematics devoted to the study of discrete objects. Here, discrete means consisting of distinct or unconnected elements. Actually, theories have many reasons that why you need to learn discrete mathematics. I'm gonna tell you why. First, if you learn these lessons of discrete mathematics, it is into the door of the data structure or the algorithms or the database theory, or your profession is what? Your profession is data science. It is the best way to into this data science. So I think you have to learn discrete mathematics.
Hi guys, my name is Arman. I said about logic. What is the logic? The rules of logic define the exact meaning of mathematical statements. They help us understand statements like there exists an integer that is greater than 100 that is a power of 2. And for every integer, the sum of the positive integers not exceeding n is n plus 1 multiplicate n divide 2. Logic is the foundation of all much reasoning and has practical uses in designing computers, artificial intelligence, computer programming, programming languages, and various areas of computer science.
Hey, next we're gonna talk about proposition. What is proposition? Proposition is a statement. First is a statement, and second, we can find the truth value of proposition. Maybe it is true. If it is true, we use this. If it is false, we use this. And it means we can judge the truth value of truth or false, and also it is a statement. And this is connected to become a reason that what is proposition. And proposition we can, and also next we're going to talk about how we can judge the proposition is proposition or not proposition. The first proposition. First, let me take example. It's about proposition. Washington is the capital city of America. It is a statement, and also it is true, so it means it is included to proposition. And second, 1 plus 1 equal to 2. It is a statement, also it is true, it is include proposition. Next, 4 plus 1 equal to 400, right? It is statement, yeah, but it is false. It is false, but it's not mean it doesn't include proposition. Also, it is a proposition. Just because it is statement, also we can find the truth value, judge true or false, whatever. It also includes the proposition. Next, what is not proposition? In there we have x plus y equal to 3. In there, x and y, we don't know the really mean, the really value of these two value. We don't know that value, so we don't really can understand it is include or not include to the proposition. Next, what time is it? It is a question, so it is not proposition. Next, don't do this. It is an exclamatory, so it is not include to the proposition. No. I think you guys can understand what I'm talking about, right? So next also has a compound proposition. What is compound proposition? We know in mathematics, many statements are constructed by many statements like American is a good city. Also, American is not good city. I love American. Blah blah blah. There is have many statements. All right. I think you guys can understand this. So let me take an example about connected preposition, like negation Q or P. This is all we call it compound preposition. I think you guys understand. Thank you.
So we continue our lesson. Now we talk about negations. Negation in logic is the operation of reversing or flipping the truth value of a statement. It is often represented by the symbol negation, and it is said not, or the phrase it is not the case that. For example, if you have a statement the sky is blue, the negation of this statement would be the sky is not blue. In truth table, we're looking at Q, true and false. Negation Q, false and true. Negation is a fundamental concept in logic and is used to form complex logical statements and make logical disjunctions. Today, we know two fundamental logical operations. They are conjunction and disjunction. Conjunction is this operation is represented as P and Q, and is true only when both propositions and P and Q are true P and Q are true. In our example, if P represents today is Friday, and Q today right today recently. The conjunction P and Q is true only on rainy Fridays and false on any other day or on Fridays when it is not raining. And conjunction. Disjunction, this operation is represented P or Q. And it is true when at least one of the propositions P or Q is true. It is false when both P and Q are false. It is similar to an OR operation. In truth table, this is look at and this truth table. The provided truth tables show all possible combinations or truth values for P and Q, and the resulting truth values for these logical operations. These truth tables are fundamental tools for understanding how logical operations work and in another logical deductions.
Next, we're going to talk about exclusive or, implication, and then be conditional. So first, let me talk about inclusive or. What does that really mean? Okay. So first, we have P and Q. If only one by them is true, then is truth value is true. Let me take an example. We have a true, right? These have two true. It's not, it's false. And we have true, false. There is have one that is true. It means the truth value is true. Next, false, true. There is also same to the second. There is have only one is true. The truth value is true. Finally, false and false. There's nothing is true. So, oh my God, that is false, right? So, and there's we can denote it by this symbols, right? Like this, or X, or. That is exclusive or. Next, we have the implication. Let me talk about implication a little bit. First, we have the statement P, implication Q. The proposition is false when P is true, Q is false, then the finally truth value is false. We can use this way to take this truth table. Let me take example. The first is true. True is true, right? Second, the first is true. That it means P is true, Q is false. You know what I'm talking about in this way? We know the first is P is true, second Q is false. It means really the finally conclusion the truth value is false. The other ways is false. Whatever, I don't know, maybe false, true. We don't need to conclusion it or think about it. Just true. False is true. Just in there have a different is true. The first is true, second is false. It's finally conclusion and the truth value is false. I think you guys can understand. And the first we know this, right? P, implication, and Q. The first K is hypothetics, and second Q is a conclusion. And also we have some statements like this. If Q, then Q. I think it is easy to understand for you guys. The last one is be conditional. You know, be conditional is have many different implication and exclusive, right? So we use this symbol to denote it by be conditional. This, right? This symbol. And also, let me talk about what is be conditional. Let's constructed series have P and series have Q, right? We use this symbol to denote it Z, right? Next, we can use the truth value to denote them. First, P is true, Q is true, Z has the same value. You know what I'm saying? Same value. It means it is true or false. Same value, alright? The first, we have the same value. Choose, it's true. Second, true, false. Zero has the choose value, right? So it is false. Next, we have false or true. It's same to the next. Second, it doesn't have the same value. It is false. The finally is false and false. It's good because it is have they have the same value. So it is actually is true. I think you guys can understand this. This main problem is they have the same value. Whatever is the first, whatever is the second, whatever it is true, or whatever it is false. It is just true. I think you guys understand. For the exclusive word, we have the. Let me take an example for a second, right? In our real life, for example, when I go to the restaurant, I can order either a cheese or a pizza, right? But I cannot order a cheese and or pizza at the same time because they are the different delicious. It is this in this conclusion very same to the exclusive word. I think is easy to understand. Thank you for your guys watching. I see you guys next time. Next, we have the translate the English statement to the logical expression, right? For example, these have a statement like, if you hard work to the exam, you will pass exam and you will so happy. It is a just simple statement in English, right? So if we want to translate this English statement to the logical expression, we have to find some of proposition that the statement becomes a proposition. First, we have the P. We find these have sentences like, if you hard work to the exam, that become to the P. If hard work to the exam, right? Second, we watch it this. We see these have also. You will pass the exam. That becomes a Q, right? You will pass the exam. And next, finally, we find these have. You also happy. Also, we let it become our proposition, right? You will so happy, right? And next, we have to find the logical connectives. In here statement we have the if, right? And well and in. Actually, they are logical connectives. Like if and then it is a logical like P and Q. We can use this logical. Let it become logical expression, right? So first, let's set. Don't watch that. Okay. First, P. Right? We have P. You will work to the exam. And next, if you and we use the implication. Because if then it is belong to the implication, right? If you hard work to the exam, you will pass the exam. You will pass the exam is a Q proposition, right? And this is, but it's not and. This also has and connectives. And connectives is like this, right? And you also happy. Also, we use this connectives, and you also happy. There is R. So finally, we do this, like translate the English statement to the logical expression. P implication to Q in R. Thank you for you guys watching. I see you guys next time.
I teach you the next example. You don't pass the exam if and only if you don't hard work. The first situation is P. You pass the exam. You pass the exam. The second situation is you hard work. You don't pass the exam. It is situation P. Negation P. You don't hard work. It is situation negation Q. If and only if it is biconditional. You don't pass the exam, and if and only if you don't hard work. It is negation P, implication negation Q. I'm sorry guys, negation P, biconditional negation Q. That is all. Goodbye guys.
Goodbye.
Nice.